Hi, this is the first video in a small sequence designed to introduce the ability to solve linear algebraic problems using the computational software package Matlab. This video is going to focus just on a general introduction to Matlab to get you started. First of all, where can you find Matlab? This is often the first question students have. Stony Brook has a site license that lets every student download and run Matlab for free. If you can go directly to the website here or simply type in Stony Brook Matlab to Google, and at least for me it was the first hit. This will take you to the Do It page that tells you everything you need about installing, how to create a MathWorks account, which is necessary for the licensing, how to activate the software, and how to actually and the link to download and install. It's fairly straightforward. There's instructions for each piece here. I have also put on Blackboard a few references to Matlab in addition to the material in this video. I've included a short introduction to the key fundamentals. This is a document that I've written for a number of courses in which I introduce some of the basics of MATLAB. In addition to that, I've posted a link to the official reference guide published by the company that makes MATLAB, MathWorks, to all of the major features of MATLAB. This is there just for anyone who happens to want to deeply more explore MATLAB. It's in no way required or even recommended that you read this. They're purely there for interest of motivated students. There's a second guide that I also have posted there, again, for people who are interested in digging more into MATLAB beyond what we're going to do in the class. I do recommend that you read the little document that I've written as a summary of the key fundamentals if you've never used MATLAB before, but we will also be covering everything in the video. So let me start off with a very, very brief and simplified introduction to computing and what computer programming really is for those of you who haven't done any of it before. I understand that some people have never done any programming, and the idea of doing something like this can be a little bit scary. So I want to start off with just a very qualitative, descriptive introduction of what do we really mean by computing or programming. In many ways, there really are two fundamental things that we do in most computer programs. We store information into the memory locations of a computer. We call this variable assignment. And we do things with that information. We calculate new values based on that stored information. We perform what we call operations on those variables. There is also, if you want to really be pedantic, there's a step of reading from memory that is somewhat a separate task, but that's not something we usually have to actually think about, that the reading from memory happens automatically in most languages. And writing a computer program generally involves writing a series of statements or a sequence of statements, some of which that store information, some of which that calculate a new value, or which calculate a new value and store the result, combining these two things. And most computer programs involve really a sequence of these sorts of events. And it's the combination of rules of what are we calculating, what are we storing, and what order that indicates what a program does. Right? For those that sort of know more about computing and might be wondering about the missing pieces here, I have intentionally left out of this picture the control of other pieces of hardware, control of what shows up on a computer display, control of what happens in a attached device. Those are things that we also sort of do, although even in that context, the way we control devices is generally by storing values and sending that information to the device, which implements, which does what it needs to based on that information. Okay. Programming languages universally have something called flow control, or control flow functions that make it easy to tell the computer to do things along the lines of repeating a certain set of tasks over and over again, or performing a certain task only under certain conditions, or repeating a certain task over and over again until a certain set of conditions are met. And this ability to control when things happen in a well-defined fashion and are really what makes a computer more than just a calculator. They really are what allow you to do interesting things and create interesting programs. Okay. I'll be highlighting each of these in the context of Matlab. That was just a very brief introduction to computing generally. When you open up Matlab for the first time after installing it, you should get something that looks like this. The window is organized with what's called a command window, where you can actually just type things in and have Matlab do stuff. I'll discuss that in a moment. A file browser window. This will show whichever the current folder is. This usually gets saved when you exit, so it will come back to the same place. I already have a series of Matlab files here, which is why I have these listed here. It will very likely be empty the first time you ever run Matlab. And a little window labeled Workspace. I'll be explaining how each of these is used in general. Now, you can simply type things into the command window, this sort of statements that store information and create new information and so on. But in general, I strongly recommend that you don't do that. Instead, I recommend doing almost all of your work using what's called a script. Script is a general term for a program in languages like Matlab that are so-called interpreted languages that I won't really be getting into. And is sometimes referred to as an M file based on the default extension of a .m that is used to store these files. Why do I ask that you do your work in a script or in an M file? This is how you can save your work so that you can do things, save it, and come back to it later. You can't do that with what you do in the command window. Very, very helpful piece of working in a script is that the commands aren't executed until you've written everything out, until you've planned out your whole process. This lets you check for errors and double check for errors and triple check for errors, and if you make a mistake, to easily go back and correct the errors. And it also actually simplifies the process of writing code because you can copy and paste and move things around to reduce the amount of typing you need to do when you're writing things. Right, all of these and others lets you share your work with other people in an easy way by just sending them the file. Right. Now, how do we work in a script? How do we work in an M file? Well, the screen I showed before, I'll go back to this. If you click on New Script, or if you click on Open, or if you click on sort of just New and then select Script, or if you click on any one of these, double click on any one of these file names, In all cases, what will happen is a script window will open. Here, I've selected this file example syntax, and so it has popped up. A new window opens up. The editor window pops up, and actually it shifts the tab that we're in. Previously we're at home, now it's shifted automatically to be in the editor tab that contains the context of this. And this is just a file that I have some example syntax, some example commands that do some things, although not particularly interesting things, but just to give an overall feeling of how Matlab works. This code, just to sort of give you a preview, I'll go into the details of how we do this in a minute, stores in 3 variables, A, B, and C, the value 5 in A, 2 in B, and the product of A times B, that is 10, in C. This line creates an array or a vector with elements 1, 2, 3. This statement multiplies that vector by the number 2 and stores the answer in a new value. This statement stores the number 0 in the second element of vector 2. This statement creates an array, or a matrix where the first row is 1, 2, 3, 4, and the second row is 5, 6, 7, 8. And then this command puts the value 10 into row 2, column 3 of that array. So we can type things like this. When we want to run, when we're ready to run in the context of a script, we simply go and we click on Run up here. When we do that, it will execute the command. I have, before I show you the output of that, I just have a summary of how we go about storing information. A preview of it was in that previous Matlab file. Matlab has a very simple syntax, a way of storing information in a variable. We put the variable name, which can be any sort of string, any set of characters that we want to use to store the variable, then equals, and the value. The value can just be a number. It also can be an expression that gets calculated into a number. When we do this, the variables that are stored and their name will appear in the workspace window. I'll show you that in a moment. And we can use them in further commands by using this variable name. We assign variables using a specific notation depending on whether we care about a scalar, where we just use the number, something like a equals 5, or if we want vectors. Vectors we can store in 2 different ways. We always use square brackets to delimitate them, just like we often do in handwritten notation. If we use commas to separate the numbers, actually we can also use spaces. I recommend using commas. It makes it a little bit clearer. This will be a row vector. If we use semicolons to separate the numbers, this will be a column vector. Matrices, or 2D arrays, are written with the variable name equals, again, square brackets. We enter a row at a time and then separate the rows by semicolons. So we rate 1, 2, 3 would be the first row. 5, 4, 5, 6, we should have a comma there, would be the second row. 7, 8, 9 would be the third row. We can also store information into individual elements of an array. So U2 equals -1 would store the value -1 into the second entry of the vector U, and M13 equals 5 would store the value 5 into the first row, third column of the matrix M. This is the standard notation for storing variables. to see how this plays out in the example we gave. If we had hit run on this, what we would see is two things happen. The command window gets some output. We could actually scroll up here to look at more if we wanted to, but we can see the tail end of it with our array A stored as 1, 2, 3, 4, 5, 6, 7, 8. And then after we've executed this second command, the second row, third column value gets replaced with a 10. We see that the workspace now is no longer empty, and it tells us what variables we have. We have a variable A, array A, B, C, vec A, and vec B. These are organized in alphabetical order, and it tells you what values they hold in them. Okay. Now, one thing that you will sometimes see in my code, and is a very useful thing to know, is the use of something known as output suppression. As we see in the sort of output from this slide, when we run a program, when we run our code, it outputs everything that we've done. Sometimes we want this, but this can also be really messy. If we're working with really big matrices, it will try to print out big matrices to the screen, and it will be very hard to understand what's going on. If there's a lot of intermediate steps to get your final answer, maybe you do 1,000 things and then you only want the last number. Why print out all of those 1,000 things? We can avoid that outputting everything that's done by simply adding a semicolon to the end of a line. It's very common to see people end every line of their code with a semicolon. That's what I usually do. And so if you ever are looking at Matlab code and you see semicolons on the end, that's what's going on there. And you can use it if you want or not, depending on what you prefer. I'll show an example. Here I've taken exactly the same program, exactly the same script, and all I've done is I've added a semicolon to every single line. If I do the same thing, click run here and see what happens, we will get different output. All that happens in the command window is it says, I ran the command example syntax. And nothing else is output to the command window. But the workspace shows that we've stored all of that information exactly as we wanted to. That's what output suppression does. Okay. In addition, to making it easy to store information, Matlab makes it very easy to do arithmetic with scalars. This summarizes how we do so. Addition, we just use the plus sign. So k equals -4 plus 3 would store the value of -1 in k. We can do this with actual numbers or with variables that we've stored scalars in. So if we have already stored a number in a and b, we could do a plus b, and that would store the result in k. Subtraction, multiplication, and division all work in exactly the same way. We use the subtraction sign or the hyphen, just a hyphen on your keyboard to do subtraction. We use the asterisk to represent multiplication. We use a slash to represent division. And with all of these, we can use numbers, we can use scalar variables, or a combination of the two. And we can build up more involved expressions using multiplication and division. You can use parentheses to define order, and so on. Right? We can also take powers of scalars if you want to square or cube something by using the caret symbol, or the little up arrow, some people call this, or a hat, to represent the power. So this reads as -4 to the power of 3, where I've used the parentheses here to make it clear that I want the -4 as a whole to be raised to the power of 3. And we can do this with variables also. Right? Very straightforward. Now, scalar arithmetic isn't usually what we want most of our programs to be working with, especially in the context of linear algebra. The great thing about Matlab is that it is just as easy to do arithmetic with matrices and vectors. If you've defined vectors, u, v, and matrices a, b, you can add those vectors together and store a new vector. Add matrices together, store a new one. Subtract vectors, subtract matrices. And this will follow the standard rule for matrix addition and subtraction of adding or subtracting corresponding elements. If you have two matrices of the appropriate size, you can multiply these together, again using the asterisks. Matlab will give you a warning and not do anything if you try to multiply matrices that are not the right size. We can take the transpose of a matrix by using the single quote symbol. Right? So all of the things that we want to do with matrices, multiplication, addition, subtraction, and again we can build up larger expressions of these, we can do with really a single character in Matlab. Really simplifies the process of working with Matlab, helping avoid making the numerical errors that are so easy to make when you're doing things by hand. We can also take matrix powers, a to the power of 2, as long as A is a square matrix, and so this is well defined. Matlab will do A times A, and we can do A to the third or A to the fourth or so on, and Matlab will do the appropriate thing. Some examples of how this works. Second example syntax file, and I'll put these files up for download so that you can take a look at them and play with them. This file sets a scalar of A, a vector of U, and a matrix of A, and then does things with them. We can compute another scalar combining A squared minus 5A plus 2 minus the second element only of U plus the 2, 1 element of A, stores that into B. We can create another vector by multiplying A by a scalar. We can create another array which in this case will actually be a column vector, by multiplying 1/2 by this matrix A and the transpose of U. We can do all of these things. If we hit run, it will output things to the screen because I don't have semicolons on the last 3 lines. It will not output the first 3 things to the screen, but it will store all of this information in the workspace. Matlab also will do things like Gaussian elimination for you. It has a built-in function, RREF, for reduced row echelon form. And this will, given a matrix, perform Gaussian elimination and return the reduced row echelon form. So going through all the steps of forward elimination and back substitution. So to solve a linear system like this, we convert to augmented matrix form and then just type this augmented matrix in. 1, 1, 1, 5, 3, 2, 3, 4, 7, 0, 1, 2, 2 as the 3 rows separated by semicolons. Once we have the matrix inputted, it's as simple as typing RREF A and Gaussian elimination will be done. Gaussian elimination is one thing Matlab can do. Almost all of the things we explore in this class also have simple functions that Matlab which will allow Matlab to do them for you. It is an incredibly powerful tool for linear algebra. Right? The last thing I want to end with is a brief introduction to one of the simplest ways of controlling the flow of a program, and this is a for loop. A for loop is something that we can use to do something over and over again. We can use this to repeat a task a certain number of times, right? So I could, for example, write code like this. For I, we read this as for I equals 1 to 10. Then we put a command and then an end. And what Matlab will do is it will set I equals 1 and it will calculate this, I equals 1 squared. And then it will make I equals 2 and it will calculate A equals 2 squared. And then it will make I equals 3 and calculate I equals 3 squared. And it will do this until it does it for I equals 10, and then it will exit and stop. We can use this just to compute a sequence. We can also use the same structure to loop over the elements of a vector. Right? Let's say that we wanted to create a vector that had the square of all of the elements of another vector. We could say for I equals 1 to 5, this is a length 5 vector, xi equals ui squared. This would create a new vector x whose elements are the elements of u all squared. We can do what's called nesting loops, writing for loops with more than one variable to do something like to go over all of the rows and all of the columns of an array. So a structure like this for I equals 1 to 4, for j equals 1 to 5. This will make I equals 1, then j equals 1, j equals 2, j equals 3, j equals 4, j equals 5, then I equals 2, j equals 1, j equals 2, j equals 3, j equals 4, j equals 5, and so on. We end each of the fours with an end, and in this case, what I'm saying is store in entry ij, so the ith row and the jth column, the value of this. -1 raised to the I plus jth power. So if I plus j is positive, this will be +1. If I plus j is negative, this will be -1, multiplied by the sum of I and j. So when I and j are 1 and 1, this will be 2. When I is 1 and j is 2, this will be 3, and so on. Right? Just a few little examples of how you can go through for loops. That ends this brief introduction to some of the syntax of Matlab. In the next video, I will go through a few examples of applying Matlab to some of the sample linear systems that we've already explored in the course. Thank you, and goodbye.